Okay, I'm Mr. Bloom. This is Geometry Review 830 and 834. We're doing our first day notes. Okay, we're doing it fifth hour. They're all staring at me like I'm like one foolish human being, but that's okay. How you behave will be played back to your parents. Okay, so here we go. X equals 5. Put in, when we're doing this type of stuff, this is an evaluation, put in the value that we're using. So often I have people do this, and it's negative 100 they come up with, okay? Because they do it so fast in their head, they go 2 times 5 and they square it. And it should be 5 squared and negative 2. Okay, so 5 squared is 25 times negative 2 should be negative 50. So often they can rush off and just do the wrong thing. Although they multiply things so fast, they're like, well, you know, I know how to do this. And they're like, okay, so just be careful. These are the little mistakes that you make in the test or quiz. You go, oh, I can't believe I made that dumb mistake. So just slow it down a couple ticks. Write down what you're doing, because that's really what I expect you to do to show your work. Now, I'm not saying you got to throw all your thought process and write down everything you're thinking, but what I want to see is, in an expression that you're evaluating, you want to put in the 5 for x and the negative 3 for y. So we got 5 plus 5 times negative 3 divided by 5. Now, according to order of operations, I have something called PEMDAS. Okay? Parentheses, exponents, multiply, divide, add, and subtract. That's our order of operations. So what I do is I kind of start on the inside here. And I got 5 and negative 3, so that's negative 15. 5 plus negative 15. Now I'm going to put it in parentheses, kind of to emphasize the fact I still have a negative sign there. Okay? Now I'm going to divide this by 5. My concern about this when I do this is I'm not going to go to 5 plus negative 15. I go to negative 15 divided by 5. So now this is plus negative 3, because that evaluates there. And now I can finally find my final answer. 5 plus negative 3 is 2. Now, according to what we've done, we've evaluated according to the order of operations. Okay, so make sure you're getting her done. You got a question? Okay. Now, when we do order of operations, we have grouping symbols. We have parentheses, we have exponents that kind of are inadvertent grouping symbols, but we also have fraction bars. They're grouping symbols as well. And this is a fraction bar in number 9. Okay? In number 9's fraction bar, what we've got to do is 5 is on top with 1. Negative 3 is on the bottom. And we do everything that's on top first. Everything on top first. So that's 6 divided by negative 3. And then we remember that, you know, division by a negative is, you know, a negative answer. But I've got 6 divided by 3, which is negative 2 here. Okay? Are there any questions right now? Right now at home, I got people raising their hands. Sorry, guys, this is a video. Okay, so only the people in class can answer questions. Okay? So we're going to go on to 6. I'm going to have you guys do that on your own. I'm going to walk around a little bit. I'm going to stop the video right now. Back, we're looking at the value, the solution for 6, and y goes in for negative 3, and I got negative 2, and I got that negative 3, and that's squared. Now, a lot of people are going, Bloom, why in the world are you using all those parentheses? That's so confusing. Those parentheses are there to let us know that we're using negative values, okay, to make sure it's not a subtraction problem. So when we're doing this, I got negative 2 times negative 3. That's 6, positive 6. So I got 6 squared, which then becomes 36. If I didn't show that parenthesis, even though I just wrote the problem down, I could go negative 2 minus 3 and mistakenly say it was negative 5 squared is 25. Okay, so I've got to be careful of what I'm doing and how I'm doing the order of operations and showing my work. In problem 10, the reason we're doing 10 is this sucker right there. It's not a multiplication sign, it's subtract. And it's why subtract everything that's in parentheses. When it's just numbers, we do all the stuff in parentheses, and then we just subtract the number. But because we have variables, sometimes we're restricted in what we can do. Fortunately, we are plugging in value, and x is 5, and y is negative 3. So I get to say negative 3 minus 5 minus a negative 3. Like that. So now I can combine the 5 negative 3 inside parentheses first. So this is 5 minus negative 3, which is just 8. So negative 3 minus 8. Well, that's kind of cool. I can talk about adding opposite, which is a negative 3 plus negative 8. Okay? And I get myself a negative 11. that's my solution. But if you notice that the more difficult it becomes, the easier it is if I just write it down and show my steps. If I just try to race to the end, I'm going to make mistakes, okay? Unless I'm incredibly good at it. Okay, if I've done it before, if I practice a lot, sure, you'd probably be more efficient and be able to do it without mistakes. But be very, very careful. What I'd like you to do is, for the folks at home, we're going to have you try it, okay? We're just going to go on with our time constraint today with the other things I did for the first day and try to get it done together in class. Okay, so turn it off if you're at home. For you folks in class. Okay, welcome back. You turned it back on. All right, so now we've got 2 times 1 minus 5. And we've got negative 3 minus 5. Okay, so plug in our values and now we evaluate. Evaluate the stuff inside. I've got negative 4 times 2, which becomes negative 8 on top. And I got negative 8 on the bottom, which will evaluate to 1. Remember, when I'm asked to evaluate, I'm given values for x and y, and I'm asked to plug them in, or given variable values, I should say. And I'm asked to plug them in and evaluate what the actual number would be. And it's just helping me work with my word operation skills. That's it. Okay? Just PEMDAS. Okay? Please excuse my dear Aunt Sally. If anybody's seen Eddie Munster or the Munsters, it's an old serial. Late 50s, early 60s, it was on TV, it was black and white. Herman Munster was the father of the family, he's Frankenstein, kind of. Their son, Eddie, is kind of a little fledgling vampire, but we came up with, a few years back, Push Eddie Munster Down the Sewer, for people to remember because they like the Munsters, and it's kind of a cool thing. So go ahead and YouTube Munsters, but, if anything bad happens, I apologize. It should be, the serial black and white. It's pretty fun and entertaining. Okay, so I'm a little lame as far as my TV is concerned, but it's pretty good. Now, as we're going through, let's look at 13 and 14 real quick. When you first stare at them, do you notice that they're almost the same problem? They look like everything's the same. Okay? I've even had students in the past go, boom, do I have to do that one? They actually look like you wrote the same problem. It's like, it does, but let's just walk through it. So I've got x, which is 5, times negative 3, minus 5. And over here in 14, I've got x, which is still 5. Oh, minus, there's a change, negative 3 times 5. Now, remember, order of operations requires us to do multiply first. So negative 15 minus 5 is just going to be negative 20 on the left. For problem 14, however, when I look at that, I got to do the multiplication on the right side of that subtract sign. So I got 5 minus negative 15. Well, the opposite of negative 15, that's plus. So this is just 20. So actually, they're 2 different values. Okay, similar, kind of like that, but they're very 2 different values. Now that's evaluation. Okay. Now keep in mind, the ones we didn't do together, we will have you do as the assignment. Okay. Let's get on with the next page. Now, in this one, we're talking about simplification. In simplifying, we're going to do those blue ones. Excuse me. We're going to do the blue ones here. Keep in mind, when we're simplifying, I don't have anything set equal. What we do is have everything set. Excuse me. When we're simplifying, we combine like terms, x's and x's, x squareds and x squareds. If we have plain numbers, okay? But they have to have the same letter and exponent to simplify together. So keep that in mind as we're going. So now, we are at 6x minus 4x plus 8 minus 5. So 6x minus 4x is 2x. And I've got 8 minus 5, which is just 3. I am now done simplifying this problem. I can't combine the 2x and the 3 unless I know what x is, okay? And don't try to be creative, because x could be anything, okay? So be careful about that. 18 I want to do because you've seen this hundreds of times. This is the length of the rectangle, this is the width of a rectangle. This problem in 18 is just the perimeter of a rectangle, okay? So remember, this is length plus width, because if I start here, or let's start here, I go length plus width plus length plus width. 2 lengths and 2 widths. So I've got 2 lengths plus 2 widths. And that looks like the subtract sign there, so we'll get rid of that. But that's how we just distribute and combine like terms. Is it possible to build? Okay. Are there any follow-ups with what we've done so far? 21. We start distributing. Okay. -4. We're distributing the negative and the 4x together. -4x times x is -4x squared. -4x times -2 is positive because of the negatives. 8x. Because the x's are different exponents, we no longer can combine them any further. Okay? That's it, as we said. Now, if you look from 21 to 22, boy, they look the same. But in 22, I've got that subtract sign in between the leading coefficient and right there. That's important because that's saying take the opposite of everything inside. Okay, so I've got 3x minus 5 minus 2x. That's what happens with that after I distribute that subtract sign or negative sign. Okay. Now, once I do that, I combine like terms. The 3x and the 2x are like terms. It's 3 minus 2. It's just 1. So I've got x out front and minus 5. But I have to practice that. I have to be comfortable with that and able to write just x as opposed to 1x. Right? 3 minus 2 is 1. But if I just write it with the coefficient, leading coefficient not there, x alone means 1x. Let's get used to doing that. In problem 24, you've done these. December, January last year. Matter of fact, it might have been just after Thanksgiving. You did foil. Your favorite thing. When you go to a restaurant and they give you leftovers and foil. Okay? If you watch the Olympics, foil is a sword duel thing. But foil here, first, outside, inside, last. Okay, so let's talk about this. This is a binomial times itself. It's a perfect square binomial. It could be written like this, because once I write it like this, everybody goes, oh, you gotta foil that. And a lot of times when I write it the way I did, they kind of get the first and the last term, but they forget about the inside and the outside terms. So let's look over FOIL and see what happens. Remember, the firsts are squared. The outsides, minus r. The insides, also minus r. The last, plus 1. Now, remember, FOIL is a mnemonic device to help me do this in my head. Okay? It's to help me be speedier, if that can be a word. Right? Speedier. So I go r squared minus 2r plus 1 is my final answer, because I can combine my outside and inside terms. Keep in mind, this part of this FOIL is never, ever really written down. It allows me to do it in my head so I can be faster doing the problem. So my example on this is 25. Although it looks the same, it's going to look a little bit different. Okay? My first is 1, my outsides are negative r, my insides negative r, so I have negative 2r. My last is positive r squared, and I have none. Because I use FOIL, I can quickly do something that's a shortcut for distributive property. Okay? And we work with binomials, we've done it before, and we're very familiar with it. Okay? But now here's the thing. This is Algebra Review Worksheet. And we're supposed to review that harder algebra stuff. So it's there. And we'll have video on the solutions of the other ones we haven't done. Okay? Now, our next page on this, just make sure I'm not doing anything special. No, we're all good. On our next page, we're going to work with solving. So let's get to solving. Now, there are some things I'm going to do on this solving that you've done before and you haven't done before. Okay? So keep that in mind. First of all, I'm not going to show what I'm subtracting or what I'm dividing. I'm going to show the result of that. Because when we start doing proofs, I'm going to do 2-column proofs using algebra. my first step here would be, are you okay with subtract 2? So if I'm talking about problem 1, my first step is subtract 2, but I'm not going to show subtract 2, I'm just going to show its result. If I subtract 2, I get 3n equal 15. Because I subtracted 2 from both sides. And for my showing you how I did it, the 2-column proof, I will say subtraction. That's my reason. Okay? So this because of subtraction. Now, the next step is division. I'm going to divide by 3 on both sides. I'm not going to show I'm dividing by 3, I'm just going to show result. Divide by 3. Done. Okay? Now, it's implicit that I divided by 3 because 3 is no longer there. Okay, 3 divided by 15 5 times. So keep that in mind as we're stepping through these. Okay? Now, in number 4, we will do it a couple different ways. Okay? Now, in problem 4, I'm looking at the fact that I'm going to divide by 3 first. Because if this was just 3x equal 15, to find x, I would divide by 3. I'm going to treat the n minus 4 like it's x. So if I divide by 3, n minus 4 is equal to 5. Now, this trick, or this solving method, I should say, it's not really a trick. I just chose to divide first instead of multiply and distribute. Okay? Allows me to do this faster, in my head. But I know the answer before I even start. It's 9. 9 minus 4 is 5. So I add 4 and I get 9. Now, the reason why I do this, remember, I can totally distribute. Last year, you were the teacher, you must distribute. If you don't distribute, we'll cut off a thumb. Right? They're crazy about it. Right? 3n minus 12 is equal to 15. By the way, no students lost thumbs in this class. I don't know about last year, but this class you guys won't lose a thumb. Okay? We need those for texting. Right? All right, so here's the deal. 3n is equal to 27. N is equal to 9. Well, weird, it's the same answer. So do I have a choice on which one I can do? No problem. I'm not gonna tell you have to do one or the other, but sometimes it's easier. The only reason I chose this method is because 3 went into 15 evenly. If it doesn't go in there evenly, I ain't doing it that way. I'm gonna do it this way, okay, all the time, but it has to go in there evenly for me to make this work, okay? Now, because of time, we got 2.5 minutes. We're going to go to right to 10. Okay? So problem 10 is a toughie. Okay? Looks really nasty hard. I want you to look at problem 10 and then consider this as a blob. Okay? Big blob. Add 10 to both sides. So 5/7 p is equal to 40 because I'm adding 10 to both sides. I have 2 choices. Do you guys remember the rule? Division by a fraction is the same as multiplying by that fraction's reciprocal. Okay, that rule rules in this problem, right? Yeah, that rule rules. Okay, so the reciprocal of 5/7 is 7/5, and 7/5. So if I multiply 7 times 5, I get 35. 35. What's 35 divided by 35? P. So 1 times p is p, right? Are we good? On the left side. The right side, how many times does 5 go into 40? 8. What's 8 times 7? 56. So, done. Now, I could totally do that separately another way, but that was the faster, more efficient way. And I'm more than happy to step through some other things, but the class I'm currently working with is going to be done in a minute and a half. Okay? Thank you for the time, folks. I hope this is working. Now remember, I'm going to have the solutions posted of all the problems, handwritten, by the end of the day. And I will also have video of the different sections, an evaluation video, a combining like terms video, and a solving video. Okay? Thanks, folks. Have a great day.